Imagine looking up at the night sky, seeing billions of stars, distant galaxies, and the soft glow of the Milky Way, but realizing that almost everything you see is just a tiny fraction of what's actually out there. The vast majority of the universe, an estimated 85%, is made of something we can't see, can't touch, and don't know much about. This mysterious substance is what scientists call dark matter. But what exactly is it? And how do we even know it's there if it's invisible? Let's start with a passage that captures the intrigue of mystery and the pursuit of the unseen. We are encapsulated in mysteries. Our minds are filled with constellations, some known, some hidden, all pulling us onward. So what is dark matter really? Well, dark matter isn't just a catchy name. It refers to a type of matter that does not emit, absorb, or reflect light. Basically, it doesn't interact with electromagnetic radiation at all. That makes it completely invisible to telescopes, satellites, and the entire array of instruments we use to observe the universe. Despite this, scientists are almost certain that dark matter exists. Why? Because even if we can't see dark matter directly, we can see its effects, like footprints left in snow by something that's already slipped away. The most famous clue comes from galaxies, enormous islands of stars spinning through space. In the early 20th century, astronomers noticed something strange. When they measured how fast stars at the edges of galaxies orbit around the galactic center, the numbers didn't add up. According to the laws of physics as we knew them, those outer stars should be moving much more slowly than they actually are. If only the visible matter were present, stars, gas, and dust, the galaxies ought to fly apart, flinging their farthest stars into deep space. But that's not what we observe. Instead, those distant stars are whipping around at such high speeds that the galaxies stay together as if held by an invisible, massive glue. This galactic mystery challenged not only what we knew about space, but also the bedrock rules of science. The poet Rainer Maria Rilke once wrote, "The purpose of life is to be defeated by greater and greater things." It's fitting, because in confronting the puzzle of dark matter, scientists found themselves humbled by something greater than the sum of all their equations and observations. There was simply more out there than meets the eye. This invisible mass came to be called dark matter, not because it's evil or anything, but because it's simply dark to our instruments. It makes up most of the stuff in the universe, yet remains hidden. But how do we know that this explanation is correct? Couldn't something else cause those bizarre galactic motions? Over the years, scientists have looked for alternative explanations, like tweaking the laws of gravity themselves. What if gravity just works differently at cosmic scales? Yet, when these modified ideas are tested, they struggle to explain all of the odd phenomena we observe, not just in galaxies, but in the larger structures of the cosmos as well. Here's where things get even more compelling. When two galaxies collide and merge, their stars generally pass right through each other. Space is vast, and the stars are small compared to the distances between them. But gas clouds slam into each other, slow down, and heat up. Scientists have observed massive galaxy collisions, like the famous bullet cluster, where the visible matter behaves one way and something else entirely seems to be pulling gravitational strings nearby. Using clever techniques like gravitational lensing, where space itself gets warped by gravity, bending light from objects behind the mass, we can see where most of the mass is. And often, the mass doesn't align with the visible stuff at all. For example, in the bullet cluster, most of the normal matter stayed behind after two clusters of galaxies smashed together, but the majority of the mass, detected via gravitational lensing, was offset, as if ghost matter had sailed straight through, unaffected by collisions. This is some of the strongest evidence yet that dark matter is a real, tangible component of the universe, even if invisible. What's fascinating is that dark matter is not just some oddity out there in distant galaxies. It's fundamental to the very structure of the cosmos. Without it, our universe as we know it simply couldn't exist. The large-scale structure, the cosmic web of filaments connecting galaxy clusters, was shaped over billions of years by the gravitational pull of dark matter. The normal matter, the atoms that make up stars, planets, you and me, collected in regions where dark matter's invisible scaffolding was already in place, gathering under its guidance like dust settling on a cobweb. Listen to this passage about hidden forces. That which is essential is invisible to the eye. It's amazing to think that all the dazzling things we see, supernovae, neutron stars, and galaxies, are just the tip of the iceberg. The real foundation is invisible, and yet, for all the evidence supporting its existence, no one has ever actually detected a single particle of dark matter. Not with the world's most sensitive underground detectors, not in powerful particle accelerators, and not anywhere on Earth or in space. Scientists have some ideas about what dark matter could be. One leading possibility is that it's made of a new type of subatomic particle, perhaps something called a WIMP, or weakly interacting massive particle. These hypothetical particles would have mass, so they exert gravity, but would barely interact with anything else. There are other contenders too. Maybe lighter particles called axions, or even entire classes of particles we haven't imagined yet. The search for dark matter has become one of the central quests of modern physics. Giant underground detectors, buried deep to block out cosmic rays, wait for a fleeting glimpse of a dark matter particle colliding with a normal atom. Space telescopes search for the faint glow of dark matter annihilations in distant galaxies. Physicists at particle colliders create extreme environments hoping to produce traces of new, invisible particles. And yet the universe keeps its secrets close. In the words of a philosopher, "I know one thing, that I know nothing." It's a humbling perspective, and nowhere does it apply more than in the search for dark matter. But for all the difficulties in tracking down its true nature, scientists are confident that dark matter is real. If it weren't, entire galaxies wouldn't hold together the way they do. Large-scale structures across billions of light years would never have formed. Gravitational lensing wouldn't bend the light of distant galaxies so precisely. It's as if the universe is a stage, and dark matter is the set designer, building the framework on which all the cosmic drama unfolds. Every clue brings new questions. What else is out there, shaping the universe in ways we didn't expect? What's the true story of matter and energy? And even, what does all this tell us about our own place in the cosmos? We tend to think of ourselves and our planet as something solid, tangible, the real part of the universe. In fact, the atoms that make up everything we know are only about 5% of all that exists. The rest is a cosmic missing piece. Dark matter fills the spaces we thought were empty, binding galaxies, stabilizing orbits, and giving the universe the structure needed for life to ever have a chance. It's not just a footnote. It's crucial to why we're here, able to wonder in the first place. Let's pause and reflect. We are such stuff as dreams are made on, and our little life is rounded with a sleep. Our universe could be fundamentally more mysterious than any dream. The observable, the knowable, and the unknowable, bound together in a cosmic dance. Dark matter's existence challenges our assumptions, reminding us that reality is more profound than what our senses can confirm. Where do we go from here? Will scientists one day finally detect a dark matter particle, revealing its identity at last? Or will it forever remain, as some poetry says, the silent music between the stars? No matter how the story unfolds, the search for dark matter continues to push the boundaries of technology, creativity, and imagination. The more we learn, the more we realize just how much remains unknown. And in that unknown, there's a deep sense of wonder, a reminder that the universe is not only stranger than we imagine, but even stranger than we can imagine. So next time you look up at the night sky and see the stars, remember, those pinpricks of light are just the beginning. The real universe, its bones and shadows, is almost entirely invisible to us, yet it affects everything. And it's out there, shaping the cosmos in ways we're only beginning to understand.